Today is 3rd of August 2025. I will talk about how attention mechanism works and how all the structure works. And basically, there's input embedding. You are good at. Uh, I will use the same example, which is there is one sentence, and we will split it into three lengths of three tokens. Then each of the token will be put it here, and what they will do is multi-head attention. Uh, Wait a minute, why it's multi-head attention? Multi-head attention on QKV. Very value. And after that, we will do normalization. And after that, we will do feed forward. And at normalization, and we will repeat this.
Until when?
You can. Oh, that's a good question. We can choose it, but it's more related with performance of the model. So it will be multiplied by n.
So less repetition means better performance, or
It's kind of a lot, and you can think of this as one module, and we usually repeat it a lot. For n and 1 year. There will be n times layered. This is actually I don't want to focus on here, but this is very important part, which is before the transformer, there is not really modularized architecture, but because of transformer, it is actually simpler than RNN, but they made modularized architecture, so it becomes n times they can put same things. That's the reason LLM comes up. This is kind of very important structure for LLM. Because of this pre-trained era come out and fine-tuning era come out. It's really related training. There will be training in the forest. Because of here. That's very good question. Think about. And there's also decoder. Encoder just input the things, but for decoder, what they do is they do one write shift. So there was 3 token, but this time there is 1 token here, and second token, third token, and here there is kind of placeholder comes in, placeholder. So how decoder works is from this, they will predict next word. And from this, they will predict next word. The thing is, from here to here, they predict next word. They will do Q query value attention between these 3. And before that, these 2, and before that, this one. This is a bit interesting. Wait a minute. How can they only placeholder can predict next word? I think I should prepare it for my next. And they also do same positional encoding. And it's the vectors format where the positional encoding plus word embedding, positional embedding plus word embedding. And what they do is multi-head attention, similar with this one, but what they do is mask multi-head attention, which is related with padding. You can ask why they are being masked attention, because it's kind of simple reason. Because when they predict next word, they use only previous word. So when they do attention, they should mask the afterwards, after the word after the what we are going to predict. So that's the reason kind of they are doing masked attention. Can you understand it? Hmm. Wait a minute. When we do attention, what I showed you was if there is three words, then there will be uh, three words with two words dimension. If word dimension is two, if if dimension of word is two, then value matrix will be 2 by 3 matrix. Is value matrix, and attention weight will be 3 by 3 attention weight. This is what I told you before. Can you remember it? So like there is Q and query. I mean Q query and query. Yeah. This is value matrix for query and keys inner product of or things each other is 3 by 3. But in this case, if we do this, then this is what we did it in embedding, input embedding. But in this case, then we are calculating, we are doing computation for every each other. Like let's do free diving, then they are computing each other, right? But in this case, what output embedding do is basically they want to predict the next word. So let's do free diving. If you this is Plato for there will be let's will be here and do embedding let's do free diving will be here. From let's you should predict to predict what they should predict the next word. But while predicting, if you are computing all the metrics between let's do and free diving, they actually show the answer. So while training, they should not see the answer. So when we calculate embedding, part after the let's will be masked, so they can't see what it is. I'm actually a bit curious that how they can be actually calculated either with zero or something else, or some masked value. I will present it in the next time. Anyway, important thing is it's masked. I should search for masked value. Then after that, they will do normalization. And when we do multi-head attention here, they are using input embedding wizard and put it here together. So when we do query key value attention, some part of query and key is they are using the value of here. Detailed thing for here is I'm not ready, so I will present it in 30 minutes later. And after that, normalization again. And after that, we will do feed forward. Feed forward is kind of I will just explain it that it has unlinearity, so they can represent more functions. I think I start from look for here and normalization, and what they are doing is doing softmax, so change it to probability and output the probability of what should be next word. And the highest word with highest probability will be predicted. Do you have any questions?
So your explanation is about how machine learn from natural language material.
Yeah, and this is how
And they have
GPT works, how transformer works. And GPT only use this part.
but
GPT is using this part.
I think ChatGPT have to predict the next sentence because they just uh get the sentence from user. So
Oh,
I
yeah,
really
yeah. I will explain you again. ChatGPT get the query from the users,
Mm-hmm.
right?
Mm-hmm.
That's where things I put in here.
Mm.
Then what ChatGPT do is by embedding, so change the vector, change it to vectors, and for each of the word, let's say you just really put it. Let's play
Free diving.
free diving. Anyway, let's let's do free diving. Really, ChatGPT. Then ChatGPT will probably answer something, right? How ChatGPT works is they are doing calculating attention metrics and attention with each other, and making sentence, and word, and return.
Mm. Choose the word which has
The
high
highest probability each of the word. So how they generate the sentence is
not relativity. I thought they consider the relativity between the words using
yeah,
vector.
right here, right. But okay. So what is your specific question? Or do you think it's contradiction between calculating the similarity between each other and predicting the probability output?
Mm, I don't understand the overall process.
Hmm. Is it make sense that you're not able to connect ChatGPT that you are using and this diagram here?
Kind of. You use the example like let's do free diving.
Mm-hmm.
And you make they make attention weights table.
Mm-hmm.
Okay, and they use that table and what they do, they predict.
Mm-hmm.
So I don't really understand why they predict to make a answer about my query.
How they really answer.
Because I try to understand it by thinking about ChatGPT.
Mm-hmm.
And I don't really know about this field, but I thought ChatGPT changed my sentence into the word they can understand, and they find the word that has a high relativity to answer the make sense sentence.
Mm-hmm.
So I kind of don't understand where they use the predict word in that process that I imagine.
Okay, then I will answer it next time clearly. In 30 minutes later.